I think event modeling makes it tech agnostic, so there's not a feature of any particular language that we have that actually enables polyglot kind of approach where you can have parts of the system written in one language, parts of the system in another, and they will work seamlessly. They will click together like Lego because you have those really well-defined contracts. Defining contracts is something that API proponents have been talking about for a long time. Really good contracts are something that's going to keep your system, really good and healthy and have few defects and have fewer problems. And so we take that concept to the extreme because for each workflow step, as you're going through the thing, through the system, and the state changes bit by bit, each line before system being this state and this state is a form of contract. So there's really clear pre-conditions and really good post-conditions for every step of these workflow steps. And so you get these contracts for works.
Morning person or night owl?
Used to be night owl, morning person for productivity now,
Favorite book?
Oh boy.
Mention a few books.
The favorite technical book, the way it's put together, is Michael Feather's Working Effectively with Legacy Code. Even though I'm not doing TDD, I think the structure is really good. Concept is in the first 1/3, last 2/3 is all the patterns and how to apply them. There's a really good format, and I think it's really good in terms of friendliness to learn stuff, head first design patterns, to really make it fun to read through a lot of dry stuff. That's another really good book. For an exciting novel that's real, Ghost in the Wires by late Kevin Mitnick, about a hacker running across back alleys being chased by the CIA in helicopters. Doesn't get better. Those are good books.
Hey everyone, welcome to today's episode, where we step into the brilliant world of software architecture, but not in the way you might expect. Our guest, Adam Dymitruk, is a visionary force behind event-driven systems and the creator of event modeling, a groundbreaking framework that's changing the game. With over 3 decades of experience, Adam has not only pioneered innovative techniques, but also bridged the crucial gap between business strategy and technical execution. Now, imagine a world where every business process change is seamlessly integrated into your system's very DNA, creating a living, evolving artifact that brings both technical and business teams together. That's the power of event modeling. Today, we'll uncover how Adam's approach is reshaping the way we design, build, and collaborate on these systems. As Eric Evans, the creator of domain-driven design, famously once said, the most fundamental requirement for any system is to clearly communicate the understanding of the business domain to all its participants. Adam has taken this very principle to the next level, building upon foundational ideas to craft his own revolutionary approach. Today, we'll deep dive into how event modeling is transforming the way we think about system architecture. Adam, welcome to our episode. Welcome to the show. It's a pleasure to have you with us today. Before we get into your contribution to software architecture and event modeling, please tell us a little bit more about yourself.
Thank you for that lovely intro. I was like many kids of the last half century, well, maybe not half century, maybe at least 40 years, I think, where I got interested into computers I got interested in computers at a very young age. I specifically started to program when I was 9 years old. So this is very much kind of a dream come true for me to be able to work in the industry that allowed me to basically play as a kid. So hopefully that rubbed off in the right way. But starting at that very young age, I think I developed the skills to teach myself with no real help back this is in the 80s. So there's very, very few. There's certainly no YouTube channel to learn how to program anything. And so I taught myself out of a manual, starting with my real foray into anything significant was to learn assembler to be able to program games, because the interpreted languages at the time, mostly, BASIC on the Commodore 64 or something like that, was not fast enough to make a game work. So I taught myself how to understand the CPU and memory and those interactions, but also to develop really good habits for programming. Especially since I didn't have a disk drive to store my programs on. We were not, we're a poor immigrant family, so we didn't have money, and so I had to turn off the computer every night, which meant my programs went away. So I was writing them down on a piece of paper, and then coming home from school the next day, I would put them back in. And this is the day where you're monopolizing the television set, because there was no monitor, so you're in the living room on the floor with a basic computer plugged into the back of the TV. And so, of course, there was the contention for anyone wanting to watch television couldn't when I was on there. So this also gave me the bad habit at a very young age of being a night owl, which was actually a good habit in some cases for being a programmer, right? You don't really sleep. So those habits weren't the best, but they're, I guess, good when you're young and have energy to stay up late. So there's many times into my teens and so on that I would stay up late. Eventually, my parents did buy a disk drive, I think, the next year. But this sort of forcing yourself to kind of self-imposed catas for programming, because you're entering the same program and working on it every single day. So I got really good typing skills. At least they were back then, but they were for a kid, I guess, and all that. So by the time I was coming out of high school, I was already consulting. Obviously, didn't get into any really big, meaningful enterprise level contracts as a high school kid, but it did give me that entrepreneurial spirit, and I had a good mentor coming out of high school, where the principal called in, had a friend who happened to be a high up politician in British Columbia, and they kind of gave me an office automation networking, what networking was back in 1992. So, but any kind of projects that involved computers were handled by me on weekends and evenings, and I think that was a really good exposure to being able to see this also from not just get a job kind of perspective, but also how to solve problems as a business quite early on. I think I also tried to make it some sort of a consultancy with a friend that now has his own security company, kind of like Adaptec, which is my company. So we, in '94, I think we had one. Didn't last, but it was kind of fun. I don't think we had a proper incorporation, but we attempted it, and it was fun. And then, of course, after college and post-secondary education, I eventually found work in the enterprise, and boy, was that a shock. All the hard things I was doing, people were getting paid way more to double click on buttons and enter in some rudimentary code in a click event handler in VB6. That's quite a shock to me. I was really disappointed, but also happy that I was doing things that I thought were, way harder. I mean, having to learn things from a manual and then not really have any guidance, even for requirements. All the requirements were things that I could think of myself to implement and all that. So getting to enterprise was great. I worked for a telco here in British Columbia, I think back in 1998. Was kind of the first large project. And shortly after that, I was looking for, because of this discrepancy of how hard things are, it's like, okay, I can see why people are having, experiencing bugs and software quality issues. There are, while they do have a process of a QA environment, and they try to make, this is back in the days of Windows NT and those types of, Windows Server days, where you actually had to go to a server room and if you were remoting somehow across the network, you set the background screen of the production servers to red, so that, if you're remoted and the backdrop is red, you knew that, be careful, whatever things you change here, you're going to possibly take the system down. So this is, well before the days of DevOps and scripted things. There's a lot of manual configuration, especially in the world of Windows.
Right.
And up till '98, I was still just programming on an Amiga. I did C++ and C and some assembler in it, and AREX was a language. So I had a really different kind of upbringing in terms of my digital sort of journey. But I did learn an appreciation for really good technical design and things like that. So one of the things about the Amiga computers is they were the first ones to have preemptive multitasking, all sorts of really good things that the industry kind of didn't want. It's not fair to compare it to Betamax versus VHS, because I think there was some usability issues with Betamax in terms of the length of recordings. However, the computer chips inside the Amiga computer were quite advanced and good, and it was kind of a mystery why it's not being used. And so today I found myself in Linux in the same kind of situation. So, which is kind of funny. At least it's open source. So Commodore as a company, Commodore Business Machines was chopped up for profit, and all that innovation was discarded, which is sad because it was potentially a good platform. They did have some obviously security things that could have been done better. But in terms of performance and graphical applications, there was some really good insights. And I think there's a theory that Wolfenstein and that kind of stuff kind of killed off Commodore because the gaming kind of commoditized graphics, where those special chips, like the Blitter and things like that were found in those machines on the side, the co-processors on the side of the 68,000 Motorola chip were quite innovative. But I think just getting the raw CPU to do these kinds of calculations, and then of course the floating point stuff that were the the DX computers and the IBM compatibles, that kind of was the last kind of thing that killed off anything that was innovative, truly innovative digitally anyway. So fast forward to being disappointed with enterprise software. I started to really dig into patterns books and things like that, and then in the process, fell into Agile as one does when you're trying to improve things. So I was an early adopter of XP, Extreme Programming, written by I believe it was Ron Jeffries that wrote the Explained book, but Kent Beck also did a lot of Agile stuff. He works, I think, still at Facebook. I'm not sure if it's still there or not. Probably not, but last time I checked. So these were kind of the heavy influencers. And I gravitated to that because it did have some guardrails for having some sort of discipline, where I saw a lot of superficial project management process, yet, nothing really to guide implementation. And XP was kind of like the first foray into, okay, you can have something that people will listen to. And while I agreed with the Agile Manifesto and all this kind of stuff, I gravitated to the technical kind of disciplines that XP and related practices, like a few years later after behavior-driven development and / specification by example, they spoke to me because there was now some rigor to producing software. But with enough experience, I noticed that it had some issues of scaling, making sure that this was, taught across an organization. And there's still resistance to that change. I think, you could still, back in 2000, 2002, if you were in a Microsoft shop, you could still get fired for doing test-driven development or doing unit tests, because it was purely looked at as, you're entering twice as much, code to accomplish the same thing, and the question of quality was not really ascertained, or there was not enough evidence for people to believe it. So you could certainly, trying to do better. You got you could lose your job because you're not
Wow.
effective. Later
just
on,
because it's like twice the code, just because it's
yeah,
twice the
when
code,
you're
you're
unit
duplicating
testing,
code, and yeah,
twice the code, because when you're unit testing, you
yeah,
have
of course,
your class or your function that you're
of
trying to
course,
write to accomplish
yeah,
something. The idea is that you're going to have a test to guide you. And one of the
yeah,
things about test-driven development is the cycle of going through refactoring,
yes,
making your code a little bit better every time you add a new test to add more capability. So you're
of
looking at
course,
the underlying function class or set of classes or whatever it is to to improve it a little bit. And
yeah,
so that was really good. I was part of Agile Vancouver, and had people here
right,
from all over the world that were kind of tech leaders. So it was nice to be part of a community that was trying to bring up the bottom 50th percentile, make everyone better to be better
right,
software craftsmen
got
and
it,
women. And it was good. I was I think on that for about 4 years near the end. I wasn't part of Agile Vancouver from the very beginning, but later on, I did do that. So we had, if people know these names, like Eric Evans from Domain Driven Design and Martin
yeah,
Fowler from all the Patterns books, and and also,
Greg Young, and
of course, the ThoughtWorks, which is a really big Agile advocate and consultancy for many years and still is.
right,
So having people that were influential was good. And as part of the Agile Vancouver group, I was always pushing for Agile. Kind of went into the management state where people were just talking about, how do you do sprints and Scrum and all of these different things, and your attitude and mindset, which is important. But I think a
right,
lot of the Agile communities out there, lost kind of the connection to the roots of Agile, such as extreme programming and some of these other things that are on the technical level, and they were being left out. So I always thought to bring in really good people that were on the technical side. Obviously, one person that was quite important to me lives where you live, which is Calgary, right? So
right. I live
it's
close to Edmonton. Yeah,
you're
yeah, yeah, of course.
Canada, so saying Edmonton,
Yeah, not too far.
Calgary, like in
Couple
Europe,
hours from,
you're
couple hours from.
far apart. So out of Calgary, Mike Stockdale did a lot of behavior-driven development. I made sure to have people um, there at these conferences that represented these really good approaches on the technical side. So there's a kind of a high criticism of Agile by some technical folks that it's gotten to be more about management, just pure management consulting. Agile didn't
Yeah,
really have
right,
enough teeth to guide implementation. And so,
right,
but after about many years there, I got exposed to event sourcing, which is a way to treat information really at the core. I think there's a better definition of event sourcing today than
yeah,
there was
yeah,
back in 2005. But this article by Martin Fowler in 2005, I think it was December 2005, on event sourcing, was something that piqued my interest, because it had, it kind of went back to the roots of, what is information, what do we store, and thinking about the state of a system as being an audit trail was great. I made the connection later that this is kind of how systems really were managed before computers. It was all a matter of record. So no matter what, you look at really large insurance companies, et cetera, that existed hundreds, if not thousands of years in some cases.
right,
They all existed without computers, and
yeah,
somehow a lot of them, scaled quite successfully to be global. You look at the England trading companies and the Dutch trading companies, and even
right,
in Canada here we have Hudson Bay Trading Company, and they
right,
they all managed to coordinate quite a large amount of info across the world to be
yeah,
effective. So systems were already at play. This is not something that computers introduced to us. And so looking
right,
at event sourcing later, from that, making that connection that this is actually more, event sourcing is more in tune with how how people naturally organize systems, how they think of them. And it was a
Right.
statement of record. I mean, we had some of this in blockchain where we have like a growing ledger of facts and nothing can be erased. I was doing that blockchain stuff or thinking about it, of this immutable ledger stuff, before it became kind of the hype around crypto.
From Paxos, you would say, the consensus algorithm from Paxos? Would you say that was from Paxos?
Yeah. So, I mean, this is fast forward 3 years, and in late 2007, I met Greg Young, who was doing a lot of work around CQRS, which is command query responsibility segregation. He came in from a few places of background that were needed performance. And when I met him, he was working at a trading company where they were taking the live stream of order data from the Toronto Stock Exchange. And so that's quite a fire hose of information. And so you needed to look at tech that was able to ingest that information very quickly and make sure that things are written before you rely on them. And this was a financial system. So if you missed some things, your day was shot, because you needed an accurate representation of what was on the order books to make, split-second decisions about how you're going to kind of arbitrage. Or it wasn't really arbitrage. I think in the day it was playing the order books to buy up small orders to then fulfill larger orders that were from institutions. So kind of be the janitor, the kind of back alley bottle collector of orders, find all the scraps, make something big, and then you could then have a counter offer order on the other side of the books of equal size to some large institutional order, and you would then gain all the small percentages of the small orders you picked up to kind of make a valid thing. But I guess it was a lot of these institutional orders are of significant size. They were all or nothing orders as well, and so they would wait for another institution to make the other side of the deal. But this securities company kind of automated that by basically looking at the books and creating that order on the other side when they could find enough orders, small orders, to kind of gel them together, and taking on the risk of floating that transaction. But the reward was, quite good. It was almost a guaranteed 3% or more, I forget what was it per month, per week, or per day, but it was quite high doing this kind of arbitrage. And the business kind of fell over when the Toronto Stock Exchange kind of saw that this level of fidelity was either not sustainable, as more and more stocks and more trades happened, that they couldn't guarantee that all orders would be reflected in the stream. And so that side of the business had to be shut down, because there was no longer a guarantee that you could see every single order. And so there was added risk that you would miss some, and someone else would be doing the same thing, or you would actually miss a large order that was already there, that could fulfill the other side. So looking at this, that's kind of a little bit of a side trek, but this was the first time that I saw someone else trying to do something with event sourcing scale in a production system, and that kind of also allowed me to be a little bit more critical of some of the really good practices in Agile, such as mocking and fakes and stubs and things like that, where if you're doing event sourcing, you're really making fake events, but you kind of lose the need to have a library for mocking or faking. You can just directly feed the made-up history of facts and not have to juggle extra overhead for doing proper tests, unit tests and such, and integration tests that actually are fast and execute like unit tests, which was really good. So that was, that was 2007, 2008 was really where I could leave my, kind of leave the Agile mindset and get back into system design. So from an architecture perspective,
I'm going to introduce a slight context there. So thank you so much for that intense like the background that he explained. It's so fascinating to hear, Adam. I'd like to dig more. I have a lot of questions on even modeling, event sourcing, and all of it. Just taking a step back or two. So correct me if I'm wrong. So you were born in Europe, then you moved to BC. And you pretty much spent most of your time in BC growing up as a child. And you said you wrote your first program when you were 9 years old. Is that right? Uh,
Yeah. So I was born in Poland in Krakow, and my family lived in Warsaw. And then during the Cold War, there's a lot of people escaping Eastern Europe, and luckily we had the ability to emigrate to Canada through Italy, where my dad's sister lives, and she actually worked for Olivetti. So did her
right,
husband for their whole careers. So they're kind of on the technical side. My aunt has a master's in mathematics, and still in the. I remember the last kind of parts of her career before she retired. She was still, coding at the processor level for ATMs with two PCs
right,
linked to do interrupts on the processor and like really low level stuff. So she's definitely an inspiration to me for
right.
how far you can go in this career, and quite an amazing person. So it was her. We stayed with her family on the way while we waited for immigration status to be approved in Canada, and we had a choice of I think Toronto or Vancouver, and my dad picked
Right.
Vancouver, so that's why we live in Vancouver. And but yeah, that was. Yes, it's the first part's obviously coming here with $100 in our pocket as a family. There was not many things that I could have, and that
Right.
story about getting my computer was quite a big sacrifice for my family, and
Right.
they ended up buying me that computer because they saw that I was getting books from the library to learn how to program before I had a computer.
Right.
So they wanted to give me an outlet for that. And so it was a big sacrifice, but I think it was worth it for me anyway.
Did you always like computers, or like if not for computers, what else would you do when you were growing up?
Yeah, I mean, it's, my interests are a lot of nature outdoors. My dad, while having an engineering degree, also has a zoology degree. So he always took me to the outdoors. Probably one of the reasons why we're in Vancouver and not Toronto. It's really the
Right.
outdoors. So yeah, there's, I like plants and all things nature. So I'm always
Right.
trying to be out of the city. But I grew up in cities, which is kind of weird that when you're an outdoor person, but you kind of appreciate being outdoors more when it's not something
Yeah.
you're not living in the cabin all year round. And I get enough from growing vegetables on my balcony and things like that every day. So
Right. Right.
otherwise, yeah, in terms of interests, they were always on the geeky side. I do a lot of
Got it.
DIY things, or at least try to um,
Right.
create things. And I always wanted to go. Well, my dad kind of said engineering is probably good, and so I tried to follow in my father's footsteps. And then post
Right.
secondary, I did do a first year engineering part.
So he was an engineer as well, right?
My dad.
Yeah. Was he also? Yeah. Was he also an engineer?
No, I wanted to go.
Okay. Got it.
My father was electrical
Was okay.
engineer. Yeah.
Got it.
And he unfortunately didn't switch over to computers in the 80s, which would have been the smart move. So he, and
Right.
again, with the second language issue, he kind of did struggle here to kind of maintain, that trajectory for his career, as many immigrants in Canada and other places do. The transfer of what you had as your education in another country. You hear
Yeah.
about the cab drivers, the Uber drivers that are doctors back home, but here they
Yeah.
can just be an Uber driver or something because it's so hard to
Right.
transfer your skills with the language
Yes.
switch. And my dad was 42, I believe, already when we moved to Canada. So that's quite a you're
Yeah. Yeah.
resetting your ways a
Can
little
totally
bit
imagine.
to start from scratch. He did go to college and all that to try and
Got it.
translate all of the skills he had learned in a
Right.
different language into English, but that
Got
was
it.
he was starting so far behind everyone here that he was a native
Yeah.
English speaker, and was cheaper to hire because they're fresh from university, and here he was as someone
Yeah.
that's in their 40s trying to get in the
Of
industry.
course.
So
Yeah.
yeah, the engineering part I did like all of the things that engineering was about, and definitely this engineering mindset helped me with
Yeah.
event sourcing and eventually event modeling. Is really
Yeah.
to um, you know I, I would want to bring back software to be an engineering discipline. And I think a lot of people that say software engineering do it quite freely,
exactly.
realizing that the disciplines that we have in engineering do not exist in what we have in the day-to-day software development. And so part of what I ended up doing later on.
It is engineering in a way, no doubt.
But yeah, there's a good connection here because I did have this idea that I would like it. So back in 2000, kind of skipping around a bit, learning UML fully and all that was, something that did stick with me. That you should be able to plan and make schematics about how things work. Now, obviously, UML had a different trajectory. I talked to Grady Booch personally, who was one of the creators, if not the creator of UML, that these were the goals. Unfortunately, UML 2.0 was kind of taken by the community to be something else, and instead of being a notation, it was driven to be more of a CASE tool, which is like computer-aided software engineering, or I forget what the acronym stands for, but it's about drawing out your schematic and then somehow creating software that will create software for you from those schematics. I think we're today with AI, we're a lot closer to that dream. But back in 2000, this was kind of a fool's errand where, like, if you're drawing so many boxes, you might as well be typing the code. There's no real advantage, and you're not going to have someone non-technical understand the boxes that represent a class and and all of that kind of stuff, or a sequence diagram. But definitely was a fan of sequence diagrams. It was like, on paper, you would kind of have an image of what debugging a system would look like, and you could jump in, right? So I think out of all kind of surveys that I've seen about UML has 7 diagrams. Sequence diagrams are the most popular. They have like a 70%. Like, this is the one that's the most helpful. So did that, a lot of that around 2000. And then, of course, Head First Patterns book was really good. So it's weird to have this kind of background, and it's kind of why I wanted to fix what Agile kind of forced to ignore. With all the Agile just said, don't worry about the future requirements because they'll just distract you from doing a job at the current ones. And this is the idea of the backlog and things like that. But I always had this idea that, like, we kind of left software design saying, that just doesn't work. Instead of fixing software design, we abandoned software design to take on these agile practices to kind of just, make the best out of the actual cranking out of the code without, because, like I said, it's just software design is failed. It can't be done, so let's just not do it. And I think that was not the right call. And I think now with collaborative techniques such as event modeling and domain storytelling that others have made, and all of these other things, collaboration and having an idea of what the system is. Of course, a lot of this comes through from domain-driven design by Eric Evans, who invented it and wrote the famous book, I think back in 2003. The Blue Book, explaining how to kind of dissect a system properly. And the thing that I liked about domain-driven design, while the Martin Fowler architecture books out there kind of gave you and related, I'm lumping in a bunch of other people with like Gregor Hoppe and others with this kind of enterprise architecture patterns, or just general patterns in software. There was like 50 of them, and then there's some other ones on top of that kind of explained how distributed systems have patterns. By the time you're done with it, there's like 150 of them. So domain-driven design kind of said that there's only a few things. Like, you have an aggregate, you have bounded context, the idea of ubiquitous language. There's a handful of these patterns, if you could call them that, and strategies to kind of demystify complex systems to be something that you can reason about. So I really like that community, and a lot of event sourcing started in that community. So that's why when you're talking about event sourcing, there's a lot of links to domain-driven design concepts, because that's where event sourcing kind of grew up. So definitely was involved in that community for a while because of the fact that event sourcing was there. And had support there.
I like this interesting quote from Martin Fowler. Like, he has advocated event sourcing and CQRS big time, and then he said, I took that and kept it here. I mean, he said, like, any I mean, slightly offensive. I mean, no disrespect to anyone. But he did say, like, any fool can write code that a computer can understand, but only good programmers write code that humans can understand.
Yeah.
And then how do you say it has like influence, like making like complex systems like both accessible for for both the business and the developer tech teams?
Yeah, that's a good segue to behavior-driven development and specification. Specification by example. They're synonymous. Behavior-driven
Right.
development and specification by example.
Right.
Specification by example is a more easily understood term, because what you're doing is you're specifying something by giving an example of how it's used in the data that's going in. And so
Right.
this idea of having a unit test is just having something that's purely technical that says,
Right.
here is how a client of this code will give inputs and expect outputs. And so I
Right.
can use this as a test harness to make sure that I can actually have an if statement at the end to see if it did what it's supposed to do, or an assert or whatever.
Right.
But behavior-driven development is like, okay, you're right. This is not something that a human, a regular human that's not a programmer, can understand. The business person wants to know what this is doing. And so the
Right.
idea of from behavior-driven development is really something about a domain-specific language and fixtures in frameworks such as fitness and fit. In Java, most of these things that started in Java ended up moving to their .NET equivalents
Microsoft,
in Microsoft's world.
Yeah.
That's where a lot of my enterprise level kind of development was kind of shaped in. I kind of got, because the money was so good, that's where I ended up in the late 90s. Obviously, I could have ended up on the Unix side. I wish I did, but
yeah,
beggars can't be choosers. I was looking for something that paid enough, and that just wasn't where I ended up. But it did give me a good. I'm fully Linux now, so this is a good background.
Good for you.
Although .NET does run, on Linux these days, and that's kind of like the whole,
Mono, is it Mono? Is it called
Mono
like the
was
Mono?
a thing, yeah. So Mono was a project that was funded by Novell and others before, but it has a checkered history. And I think finally, it was donated to Microsoft or something. I forget where Mono. The history of Mono is so plentiful.
Right. Got it. I have one other topic. Sorry, didn't mean to interrupt.
Yeah,
one other topic.
Wherever.
Yeah. So I'm just trying. It's more.
Let me, to finish our thought. Behavior-driven development is really why I started to see that you needed something that was understood by both sides, the technical and the non-technical, the people that wanted the business problems to be solved via technical means. The technical and business people should be able to communicate effectively. And so the first foray into that was behavior-driven development. And later on, seeing that event sourcing really does naturally bubble that up without having to have any infrastructure. And then this is where event modeling came from, which was really developing a notation that both the business and tech would find equally of high value, so that they could describe what the system does. And so that actually has a lot of background, at least from the motivation perspective for me, in terms of how event modeling and why it's there and why it actually fits really good with event source systems. Although event modeling works very well with traditional systems, it just exposes the high level of coupling that you get with single model approaches.
100%. Quick question. I mean, I'm just trying to mind map this whole thing.
Absolutely.
You have a long career, Adam. You have 3 decades of
everything. Just let me know which way to go, and we'll go there.
Yeah. No, we will go in always. So I'm just trying to put it like a map on the whiteboard. So please bear with me. So something as you were growing up in your 80s and 90s, and I'm always fascinated because the first ever HTML page I wrote was in 2000, I believe. But I always later understood there was a huge wave about the Y2K and what happened around the year 2000, and how was the pre-90s, the pre-Y2K era, and how was the transition through the Y2K, because you lived through it, right? And as an enterprise software developer, so I'd love to hear your thoughts on that.
Oh, it was pretty embarrassingly simple. I mean, so if anyone knows about the Y2K fiasco, it was about the years in dates in computer systems being stored with 2 digits, which means In 1999, they're all going to flip to 00, and all the if statements that were comparing two dates now are going to be flipped around. So things that didn't run potentially could run, and things that were running could potentially stop through running.
Yes.
And the big fear was that this included, nuclear missile controls and other things, right? And medical equipment. And, are people going to be dying in the ICUs in hospitals all around the world at midnight? So there's definitely a big push by
planes falling from the sky
to go and look through the source code of everything that's running and make sure, if there are any, date comparisons and how the dates are stored, that it's not going to cause any issues. So actually at that telco that I started in, that was one of my projects in late 1999, I believe, or just middle of 99. I forget exactly. It wasn't last minute, but it was a project in 1999 for me to read the source code of a lot of, not a lot, maybe two systems or something like that, or maybe one system, maybe one large system. I actually forget exactly what it was, but I do remember reading a lot of C++ code or something like that to see if there are any of these things, and to flag them, investigate them further, etc. And so not the most fun task, but I lived through that, and a little bit of history. So this does go back to, again, having a good schematic that everyone can understand the system, not just programmers. People talk about self-documenting code, and I think that's short-sighted. I think everyone should understand how the system works, and this is why event modeling is something that
definitely
I kind of wanted to have out there.
100%. One other thing that fascinated me when we were connecting the other day, and I always had this also question about today we have, in terms of the operating system, it's either iOS or Android. There are only a handful that you can actually name it. Also with the actual desktop operating systems, it's we spoke about Linux recently and Unix, and either you have Mac or Windows dominating the entire marketplace, right? So what are your thoughts on the operating system as a whole? Do you think, is it headed in the right direction with AI in the mix right now, and for the next 10, 20, 30 decades? Are we with the operating system as a fundamental platform for everyone to work on? How are we aligned as a digital economy to scale with our current setup?
Yeah, good question. So, what is our digital life going to be hosted on? I'm a big open source proponent. Seeing my favorite platform die in the history of computing, which was sad to see. I'm a big open source proponent, especially for platforms, because I don't want that fragility. I don't want the centralized control to one company that may or may not feel like this particular approach is going to be worthwhile simply to make the next quarterly earnings look good. I think it's a high risk where companies kind of have their lifeblood attached to these quarterly reports so that the stock price does best. That's to accomplish that goal is not going to be 100% aligned with accomplishing the goal of what is best for society. And I think having open source, open standards, conventions is really good for society. Was it penicillin or I forget? There's a couple of things that are that the inventors didn't want to trademark or patent and just gave out for the world to use when there was good in it. So that's just one of the reasons that I'm a big Linux proponent, because it does take control away, especially through licensing schemes like the GPL and the related licenses, where you have this sort of need to share anything that you're going to improve for yourself, to share with the project so everyone gains. I think there's as we're commoditizing everything, especially in the world of AI, I think that's really important. I think the future is a lot brighter. I mean, you look at the adoption of Linux; it's at 4.55 of the world's desktop computers. Like they own all of the supercomputers, majority 90+% of servers. So they're in TVs everywhere. Android is like 70+% of the global share, which is good. So these are all really, really good things. Right. And even though people say like, oh, Android is just Google's thing or whatever, the core is Linux. These drivers and things like that are Linux based, and it's becoming, especially with AI, and LLMs, you can train. I can write my own driver much more easily. I did that by hand before. I had a drawing tablet. I like drawing. Speaking of my hobbies, you asked just a few hobbies. I have more. I love cartoons and drawing. My mug is Snoopy.
Amazing. Did you draw that, by the way? I mean,
no. This is a purchase. It was on sale, $6 at the store here.
Got it.
I got into art by copying comic books and especially cartoons from the Sunday comics and things like that. So even in Poland, there's things that I copied as a child. But so getting this tablet to work on Linux, I bought the latest one. But of course, back then, this was like 10 plus years ago, this driver didn't exist. But I know that the previous models had drivers, but didn't get recognized. But I could go into the source code. I had total control. I could change the, what was being sent across the USB cable. And I saw that it was identifying as this other thing. And of course, I found in the source code where it was looking for those strings, changed them. Now it was looking for it. Now I could find, the codes that were being sent across for the extra button that this tablet had, change that source code. Sure enough, all of a sudden things work. Like, wow, I'm in total control of that. And, that might have taken me, a couple of hours, 4 hours to make this driver for a brand new tablet that no one has yet made work on Linux, right? And of course, the tablet manufacturer is going to take care of Mac and Windows. But look at that power, right? Someone that's just buying it can make it work. And, that's what true freedom is being able to do those things. And that's actually being a responsible citizen. It's like, I see it the same as, recycling or not recycling. I can throw my trash on the ground or I can put it in a bin. And I 100%. See it as someone that is in this industry. We do have a duty to kind of pick up after ourselves. Just because you're an avid camper and you want the best camping experience doesn't mean you leave the campground filthy.
100%.
You clean up where you live. This is kind of a big deal to me because I think that there's a lot of excuses being made. It's like, I just need to get my work done. I'm a 9-to-5er. I want to concentrate on being the best at this type of programming. And I want to be one of the best changes I've seen is DHH, David, who's invented Ruby on Rails. He's gone full Linux. He sees that this is not just worthwhile for being a more responsible person, but it also makes you a better developer because you understand everything one level deeper. If you're in Linux, if you are able to correct the driver and all that. I think people say, I don't have time to waste for that. That's a very short-sighted thing. In doing those things, you actually become incredibly more productive at the higher level after you step back up. So I'm definitely a good topic because I think, there's a big future for that. And I think people being able to contribute to open source projects is, like I said, that driver, it took me 2 to 4 hours or whatever to custom change that code. I think that would take, 5 minutes now through Cursor AI or whatever. I use Cursor AI, any kind of stuff. And just the amount of Googling around and going through Stack Overflow answers. I mean, you're erasing 4 hours of mystery solving with maybe a couple of minutes in the extreme case. And of course, so it's changed my outlook a lot. I mean, there's a big step up to get proper IDEs like JetBrains products, ReSharper back in 2004 or whenever they came out, to the JetBrains Rider, which, works with .NET on Linux. And it has all of these amazing refactorings, extract method,
Love ReSharper.
That kind of see the entire structure of the code and they see where the references are. It'll walk that tree and change everything as if you were doing that by hand, search and replace terms. It was very tedious before that. But with the advent of proper IDEs, we have this really good, way to navigate the structure of the code to preserve its integrity as you're cleaning it up. Now with LLMs and AI,
Yeah.
that's actually been, it's not as, let's just say, mathematically correct, but
Right.
by statistics, it's able to accomplish a lot more, a lot faster. For example, 5 different refactorings I can
Yeah.
replace with a single prompt. Is it going to be
Yeah.
as accurate as,
Maybe not.
the actual separate refactoring steps in the proper ID? No, but most of the time
Right.
it is. And I'm
Right.
happy, and most people are happy to make that exchange for that
Yeah.
level of productivity. That they do have, unit tests, or they can interrogate the solution, or even just compile level tests would catch some of those problems with generated code. And of course, if you are proficient in that language, etc., you should be able to clean that up. I'm very happy that a lot of the dumb, boring tasks
Yeah.
are done
Automation.
much faster and better with
Yeah.
AI than they were even with proper IDs. Because I still
Yeah.
needed to set up live templates for classes and methods in the IDs. It was still an overhead, but
Right.
here I could get a baseline that works out of the box for almost everything because the training data is so vast across so
Yeah.
many projects. Yeah.
Yeah.
Good
Sure thing.
point.
No. Very well said. And quick thought on that. And we'll quickly segue into other topics.
Sure.
I love open source, and I see that AI is continuously crawling and continuously give the best user experience for anyone using the AI platform, whether it's Gemini or ChatGPT or any AI platform that is upcoming. And that being said, GitHub, for instance, there's a larger the entities behind it and things like that. And I'm a big proponent of open source as well. But my one slight worry is that, well, because there is a continuous crawl of all this information, and there is a large LLMs that's behind it, learning all of this. Like the GitHub code could be parsed and learned, whether it's across different programming languages, right? And would that, and of course, there's a great evolution of the Copilot existing in different IDs as well. How do you see? Of course, on one side we love open source. On the other side, there is AI that's trying to capitalize every other information that's out there on the internet. Do you think it's going to be a fat game, or is it heading in the right direction? You would think, with open sourcing everything.
That's a big concern. What you're talking about is GitHub code being used by as training data that potentially
Right.
has IP,
Right.
or it's not rightfully contributing anything back. It's just kind of not being able to contribute back to the projects that it learned from. It's a valid concern. But I'm not too worried about that. I think that if your code is really good, and it's influencing how others write code, those patterns will end up being kind of out there. So I know that's a hard pill to swallow for most when they think that their innovative ways of writing something is now being taken advantage of. But it's really, you're winning a popularity contest through these LLMs. And if you're worried about anything proprietary being there, well, don't make it open source, first of all. You can run a local model these days. There's Minstrel and Mistral or whatever they're called, but there's a lot of small ones that can run on a decent machine, and of course you can rent servers for very low prices that'll run them in private, or you can just have your own your own virtual machine that you rent somewhere in the cloud that just has this running outside of any AI company trying to see and use that data. So I don't see it as that bad. I actually, when you're moving to a different language, I think it's really fortunate to be able to get to basic operability much faster than all the katas you'd have to go through before. I mean, I come from an age when you needed to be proficient in a few languages, and to be proficient, you'd ended up, investing a lot of hours doing katas, trying to train yourself on the muscle memory for dealing with that language, or the patterns that you needed within that language. And all of that is sped up quite greatly. There's valid reasons. You're kind of, it makes you average fast. but you don't want to be average forever. So
Right.
you start to really dissect or use RAG models, these augmented models, or extra prompts.
Right.
If you're doing event sourcing, for example, your code is going to look a little different than most of the things out there. And you can see this when you're trying to automate, an event sourced solution using AI.
Right.
You're going to have problems. One of the big problems I have is, commands being used to say to issue queries, which is not something that you do in event sourcing. But the
Right.
models are not trained on data that makes it this discernible, or at least easily discernible for them at this point yet. And so there's
Right.
definitely efforts there to have smaller models work together to decompose a solution for a specific approach, such as event sourcing. And I think it's just around the corner. This is just a matter of time where we can train and have better guidance for the style of development. And of course, just the popularity of event sourcing via anything else that's out there. There will be more code out there that will allow a generation of such solutions to be more readily available, but it's not there yet.
Of course. We will jump into event modeling. Just before that, I'd like to understand from your 30 plus 3 decades of experience, what were some key milestones that you would like to highlight in each decade? And then from an approach of system design and architecture, how was the first decade, second, and the third one? And then quickly we want to transition into event modeling very soon. Yeah.
Well, my perspective in the first couple of decades is going to be quite junior because I was young. I mean, I have a lot of decades of programming experience, but when you're a 9-year-old kid, you live in a small bubble trying to make video games. So I can't really comment on the 80s. I can comment on what I learned from people like Mel Conway, who were, these people were shaping software as we kind of grew up during those years.
Right.
Some of us not even born yet. So I've learned from a lot of people that have been around in those decades. And I think in the 80s and maybe even 90s, one of the things that I learned as a milestone was just how specification and implementation were separate, and where the big design up front problems came up with and what was criticized. That was in the 70s and 80s, I believe. And Mel Conway told me this story himself about companies trying to make sure that we have both sides represented, because if you gave both specification and implementation to one company, they could draw up any kind of crazy scheme and have a larger project and get more budget, get more business. So companies did a separate thing. They'll say, we'll have one company specify the system, and we'll have the second company build the system. And this way, they can't kind of make a fake set of requirements because it's a different company making the requirements.
Right.
But it didn't solve the problem. What happened was that the companies that were specifying things, they made the specifications larger because it increased the amount of time they would spend specifying. So the problem's there anyway. And same with the implementation side. The implementation side made the argument that implementation is always going to take longer than specification. And so you still had an unsolved problem. And so big design up front kind of stems from it. And the biggest problem was that's when waterfall, in terms of talking about architecture and agile and things like that, the waterfall process is wrongfully criticized by being not iterative. And it comes from this dichotomy of having a separate spec up front by one company and an implementation done later by a second company. If you look at the definition of waterfall, it is actually iterative. There are steps where you don't do design, implement, test, deploy as 4 separate steps overall. You have these done incrementally with milestones and things like that. Also around 2000 is where we had functional point analysis, where you could say how many features there are in a project and have some sort of estimates. And so Agile kind of said this was bad. Let's just not bother designing things at all to get rid of this problem. Okay, that's ignoring the problem. That's not solving the problem. At least that's how I feel about it today. So those are the years there. And so, going back on the technical side, without the other stuff, the internet obviously defined the 90s, like email and the web.
Of course,
And so that's it. And I think the commercialization and making it ubiquitous was kind of like 2000s. was when that happened, and of course mobile devices, smartphones and all that. I think would be 2010 and up. That's when you had the most adoption. In 2020, you would have the start of AI. I think. I think I wouldn't even talk about crypto or anything like blockchain. I don't think that's a defining moment. I think people overplay it. We've been doing event sourcing, at least I have, since 2008, I think, and 2009 is the first production system I did for if that's event sourced purely. And so, that's kind of how I see it. You can see from the consumer perspective, from the enterprise perspective, I think we had messaging really kind of pick up on the enterprise, distributed systems in the enterprise. At least my exposure to it really started in 2000 as well. So, well, this was like ComPlus, and you had Corba on the other side for the Java side. So I think it's in the 90s, but my personal exposure and seeing it really kind of take off with the books from the enterprise architecture books and all that. I think it's those years, early 2000s, where people really weren't doing agile. We're doing this ivory tower architecture stuff, drawing lots of boxes about the systems and how they're going to coordinate. So and then 2010 also, that decade I think is defined by Ruby on Rails and the coffee shop developer, where you have the really hipster guy with a MacBook at a cafe hacking away Rails
with
apps.
Stickers on the laptop.
Yeah, I think that did a lot of problems. I think that attitude was like a very utilitarian. This is like, I don't need to be responsible in this ecosystem. My project is all I'm responsible for. I don't care what platform I'm running on and all this kind of stuff. I think that's where a lot of that mentality came from. So it's really good for DHH, David. I'm not going to try to pronounce his last name. The inventor of Ruby on Rails. It's nice to see him come around to the responsible side of computing and switching his entire company. This is hey.com and 37 Signals and all that. They're all like Linux now. He's done a total reversal where he was kind of like the god of the people in cafes with their MacBooks. But now he's kind of gone the Linux side. So it's like, oh no, we've lost our leader. We're having an excuse to overspend on our computers and look cool. But yeah.
No, that's fascinating. I could speak to you for hours and hours. I'm pretty much sure. But yeah, we will try and capture as much as we can today. Maybe in a different episode we'll capture more. But like here's something I want to ask.
Do this again.
I would love to. In July 2018, at the Event Storming Summit in Italy, something crazy happened. What happened? Tell us.
Yeah. So I was working already on my own company in 2015 to do event sourcing systems as the only way to develop stuff. I said to myself, I got to get out of this craziness that is enterprise with all the agile stuff and all the extra levels of management and inefficiencies. If I was to have a company, I would run it like this. So in 2015, I said, okay, time to, I can't work anywhere anymore where I'm held back from doing the best practices. And so I started small, just myself, and then hired our current CTO a few months later, and then continued on with more and more people. We were doing specification by example using events, but I put in the UX part, because one of the things about running a company yourself, especially when you don't have a lot of budget, is you don't have room in your budget for project managers. You don't have room for designers. You don't have room for QA. You don't have room for a lot of other roles. So it's like, here's your client and you need to do everything else. And a lot of that is programming, but you need that language like we talked about that the two can interface on. And so events were really a natural way of saying that. I could tell a story with events. I can say, here is a set of events that kind of tells a story from beginning to end of what happened. But also I need to know what the users are seeing, right? The UX part is something I introduced so that people could see the wireframes of, what each user sees along the timeline. And event modeling has swim lanes for each user. So if you have like an administrator, an end user, and whoever else, whatever roles there are, there's, an example of a user for each one. and you can see what screens each person sees as we go through, the story. And so this is behavior-driven development and specification by example influence of actually having kind of a screencast captured and then pasted each step along the way so you can see what's happening. And on the technical side underneath, you're looking at the state of the system, and it's very akin to having a debugging session where you're looking at the variable contents, like what each variable is set to as time passes. But you keep that at a higher level of what the state is, so you're not really interested in all the little details of what variables are going through, but you are interested in what's getting put on disk at each stage, right? And so this is the magical middle that allows tech and business to talk, is if you can talk about this, progression through a system, you can talk about it. And so it eliminated a lot of rework. So one of the things that I did is started to work on fixed costs, because when you did this design, you had little rework. And part of the problem with test-driven development and Agile is that you kind of have blinders on to the future features. And so that creates a problem, because you have to rework your code every time you get new features. And that actually is waste. If there's good reasons why that was done. But if you have small design done up front, it's not needed. You can have a much more open-close principle type of work, which means if a part's already working, that screen works to get other screens to work. You shouldn't touch that original one. With TDD and things like that, there's always this thing that brings you back to work on code that should have been finished, right? And that's a tough one for people to really understand unless they go through this themselves and prove it to themselves, which is why we do workshops and have people do hands-on stuff to kind of feel this for themselves. So in 2018, there's a bunch of influences for the way the company worked. There's domain-driven design for having good boundaries in the system. There's event sourcing for the implementation to make sure that we take every piece of information and not lose it. We always have a ledger of what happened. And that ended up being way more way more valuable than even unit tests. I would trade all my unit tests just to have the solution be event sourced, because that's how effective solving problems is when you have the accountability of how you got somewhere. So all of these things that we were doing, one of the concepts that we did was when we were looking to collaborate with our clients, we used something called event storming, which means going up to a wall with some paper on it and sticky notes and kind of going through brainstorming all of the different concepts a system will have. Alberto Brandolini came up with this. And so putting things up there is a kind of a really good way for all roles in a system to kind of collaborate together. And in 2018, there was like 25 people or something invited to Bologna, Italy, about event storming. And I kind of said, well, you guys are really, missing the boat here. You don't have your UI here. You don't have specification by example. You just have concepts. 100%. This is how you do it. And said, well, you're not doing event storming. It's not something that we're doing here. Since then, they've added some like second phase and third phase that allow you to kind of build on that. But event modeling kind of came out of that by kind of realizing that we're doing something entirely on its own, and realizing that event storming contribution was really just the workshop. That was the core. The idea of bringing people together to the same room was really from there. Event sourcing was the inspiration for having all of the events down below. Specification by example was having all of the code, all of the data points there, including what's on the screens, what people are seeing. And so that's a lot of UX, UI, systems thinking is at play. So I realized in 2018 that this needs to be its own. And so I wrote an article to explain ourselves. What do we do and what's different? And that went viral on Hacker News. And, one day in 2019, I think after I published the thing, it went ballistic. I don't know why I was getting all these alerts on my phone and all that, but someone posted the article on Hacker News and it got picked up by a lot of people, upvoted, and was a top story for a day or so or something like that. So it's a lot of exposure to it. And now there's a thriving community of people that are doing event modeling to drive their projects that way, because it's highly effective in terms of making sure that you have just the right level of specification. It's a specification that everyone can read. It's lightweight, it's simple, it has very few components to continue to that. Like I said, you could read all of these patterns books, but then domain-driven design had only like 5 or 6 patterns, core concepts, right? Same thing with event modeling. Event modeling has 2 core patterns, and you just repeat these 2 core patterns to attain anything you want. So there's a lot of copy paste your own code for the next step, which is really good. So you get a really good cadence. It's also good for language models. Like the learning set is really good because you get a really large sample size to learn from and statistically infer things from. So event modeling has this, ability to dissect things, and it brushes away a lot of other concepts. And so, I always give the example, you could put that stack of books, including domain-driven design, architectural patterns. Yes, it's good to know a lot of things, but then again, if you're trying to be effective quickly, you don't want to have your team or important people have to read, and educate themselves for an entire year before they get going. So event modeling reaches the goals of a lot of practices immediately, and you can backfill the knowledge if you want. So I want to work in a mindset of already knowing DDD really well, or knowing some of these patterns really well if I was to use them,
100%.
And having a really good solution that's decoupled, and I'm not getting rising cost curves with the size of the project. If I can do that quickly, why not, right? And so get those things, get those practices and patterns in place that will get me to those goals within 15 minutes or a day or a week, instead of a year, or whatever it takes for someone to be proficient. I mean, even TDD practitioners say that it takes decades of practice, and that's a high ask for people to say that they're going to now need to just hire experts to do things. So event modeling really does simplify the process of deconstructing a solution. It doesn't take any work away. It's not a magic bullet that's going to make you 1,000 times more productive or make your problems disappear. But it's going to give you a way to involve more people to solve problems. It's going to give you a way to communicate how we're solving things to way more people, so that things like estimates are not something that's an impossible dream now, because we have a way to decompose things to be more or less similar units of work. And so we work off of fixed costs, which is really hard for companies to do. And so, in that 2018 Bologna meeting was really where event modeling was born. It was from the realization that we are doing something unique, and no one has done something like this before. I mean, there's been attempts, but not in this exact form, where I think it involves, at least currently, the most important actors in the company, such as roles, from product owners to testers to developers to whoever else. Each one of these people is able to understand the system by doing it. Another way of talking about event modeling is really thinking about information flow. So I sometimes call it information architecture, because you actually know each data point, where it goes along a timeline of using the system. And that seems to be a really good backbone for understanding things. And it really does eliminate a lot of rework. So having to introduce another field in late stage and having to refactor code, those kinds of things go away. You really do have this idea of, again, Chris Condren, the former CTO of EventStore, one of the databases responsible, like that gives a really good place to put your events. He said, "This is what you're doing is making sure your system design has what's called information completeness, which means you understand all the endpoints of where information is going to end up. You understand the shape of the information along the way. And if you can't make the connections, you have something missing." So there's a really good way to audit before you start and realize you've now need to backtrack and refactor things and stuff like that. So this is where I think what we have is we attained small design up front, which is something that everyone really wanted, but no one ever gave, a really good answer to before. At least I tried everything and it didn't work as well as this. And I think others are realizing that this does solve that problem much better than other attempts. And so, yeah, we'll call it. I mean, we didn't set out to make event modeling. Event modeling is something that came out of effectively doing all these things that people thought were hard to do.
Did you guys coin the term in Italy, or like did it happen after that?
No, I think I did it on the plane back or something.
On the plane back.
I think so. I think I was kind of out of frustration. I wrote that initial article, "What is event modeling?" which went viral on the plane. I think it's a long trip from Europe to Vancouver, so I had some 9 hours to type. Yeah. It didn't take 9 hours. It's not such a long article, but I did do it on a flight, and then published it on the website. I figured after it's gone viral, I might as well have a website dedicated to it. Not that there's a lot of content there, but it has links to most of the talks that I do and other things there. So we have a Discord community where that's quite active, and now we have a workshop that's coming up this week. I know this is probably going to be listened to later, but so September 9th, the workshop starts and ends on the 13th, but then there's the unconference, the first North American unconference on event modeling, which is the Saturday on the September 4th. So if you're in Vancouver and can get here, definitely would be fun to have people there, because it's not just going to be event modeling. It's going to be talking about all the other related practices. There's going to be a lot of CQRS, event sourcing, domain-driven design concepts, event-driven architecture concepts, distributed computing, ledger, immutable data stores, functional programming. All of these things are going to be discussed there. So, and it is going to be in an unconference format, which, what does that mean? That means the participants vote on the topics, and we create an agenda and follow it through the day. So a really good event, and happy to finally have an event modeling event in North America. So, and that will be the start. We had one in Berlin in May, I believe, the first one. And Alexander, that's doing the proof board. So event modeling also had a whole bunch of tools that were developed. Aryan is going to be here, that developed, he's from New Zealand. He developed a tool that's quite good for, instead of just drawing things on a digital whiteboard like a Miro or things like that, it's good to have something that's more opinionated. And and that actually guides you through creating those. So there's a lot of people that created. Bobby Calderwood, who worked for Capital One, he developed one of the first event modeling boards, automated boards that you could author. He's going to be here for the conference. So there's a whole community that's, outside of my control, has created all this tooling around event modeling, and there's more and more every day. So it's quite nice to see that, if something happens to me, there's an entire, commodity. And Ryan Singer's going to be there. That we're talking about DHH and Ruby on Rails. Ryan Singer is the guy that wrote the book on Shape Up, which is followed by a lot of companies about really before starting implementing something, going from forging to really get to a point of like shaping up your concept of what you're going to do and then executing. And so Shape Up has a natural home for event modeling in that first half. So it's really good to have Ryan Singer at this workshop. Yeah. And Dave Thomas is going to be there, of course, too, who's like one of the Agile Manifesto people. And he's seen kind of the whole industry develop as well. And he's one of the first people that I met that's done fixed cost projects at scale really well. So he's a really well respected person in the community development and architecture community. He's going to be doing the keynote there on Saturday. So it's going to be a lot of fun, and it's nice to see people in the industry recognize this approach as something that is its own. I think there's always people that will throw stones, and they're saying that, oh, you're just copying all these things. But I mean, you got to build on something. Everyone's copying something from their past and their influence. They're a product of the environment. So yes, of course, I'm taking behavior-driven development concepts, but I've never hid behind the fact that I'm not. Yes, we're showing specification by example. Yes, we have UX things. Yes, we do brainstorm the initial events just like we did in event storming. This is the truth about most systems, and how we evolve concepts is really building on things that were proven before and improve them, right? Yeah. And so a lot of great inventors are really great refiners of previous ideas. And so this idea that event modeling is just repackaging existing things, true to an extent, but I don't really see the same performance with other things. I mean, we had event
Right.
storming is amazingly awesome. I love it, and that's what really got a lot of this, ability to bring all these separate people together onto a
Right.
common ground. But we found constantly in the industry, maybe it's not. I mean, I don't know. I constantly find, or people that come to me say that they love event storming, but when it comes time to implementing, they kind of are at a standstill. They don't know how to proceed. And so a lot
Right.
of combination of event storming, event modeling happens where people actually just do these concepts first and then
Right.
elaborate on the solution, and then they kick into event modeling. So the first part of
Right.
event modeling is very similar to event storming. So you can do
Right.
you can do just event modeling. It's what we do. We only do event
Right.
modeling. The first part in a lot of these things is really coming up with a common ground on the concepts and the scope and what you're going to do. And then it gives
Right.
you, if you do this and you talk about, information completeness, you then have an ability to work on fixed costs, give guarantees. Like, for example, our company gives um, free bug fixes because the code is so good when you have your design taken care of and you have the understanding of the system across the board there for everyone. You have very few defects, and the defects that you have are very easy to solve and don't have to check with 1,000 people whether it's going to work or not. And
Right.
merge conflicts don't exist. If you're doing event sourcing, you don't have schema migration nightmares. There's entire projects and companies that are just absolutely handcuffed with schema migration problems. It's not even
Right.
a thought. After, this is our 9th year, or sorry, we just finished, our anniversary was on September 5th, 9 years strong, and
Right.
this is our 10th year. And
Right.
we're continue to have more and more success with this approach.
Right.
So giving out free bug fixes hasn't killed us. Paying by fixed cost has only enabled
Right.
people to make more money that are really skilled. We had some people that, if they had some of the months they had, they could be close to making $1 million a year just from development, which is crazy.
Right.
But if you pay for value and that's what you get, as you would ask a person, how much to build this wall? They would quote you, $500. Okay, well, if the wall's not finished, you're not going to pay them the $500. When they finish the wall, that's good. And if they did a bad job and some bricks fall out the next day, you expect them to come back and put those in and fix it.
Yeah.
Software, in my experience, is actually quite a lot like the physical stuff. I know Agile people have been saying that it's not like building a bridge,
100%.
but that's only if you buy into the idea that we can't have an idea of a schematic for how the thing's going to work. If you do have that, you can treat it, because while we don't have physical materials, we still have time and effort, and those things are real costs. So I'm definitely someone that pushes for estimates for making this more of an engineering discipline. I think event modeling makes it tech agnostic, so it's not a feature of any particular language that we have. It actually enables polyglot kind of approach where you can have parts of the system written in one language, parts of the system in another, and they will work seamlessly. They will click together like Lego because you have those really well-defined contracts. Defining contracts is something that API proponents have been talking about for a long time. Really good contracts are something that's going to keep your system, really good and healthy and have few defects and have fewer problems. And so we take that concept to the extreme, because for each workflow step, as you're going through the thing, through the system, and the state changes bit by bit, each line before system being in this state and this state is a form of contract. So there's really clear pre-conditions and really good post-conditions for every step of these workflow steps. And so, you get these contracts for work. So, for example, if I'm working on a certain screen, or at least one button that's going to take my workflow from one step forward, I'm very confident that the output that I produce, or how I change state, is going to be used correctly further on by someone else. And so we can mix and match. We no longer have the limitation of pizza-sized teams. We can have as many people working concurrently as possible, as is physically possible. So a lot of these rules that are out there, we break regularly. I haven't had to have any interviews, really. Like, people just either do the job or they don't, because they get paid by each functional point. So what gain do I have by interrogating someone in an interview? If they said they can do the job, all right, then you will
Right.
get paid because you will be able to do it. If you lied to
That's
me,
right.
you lied to yourself, because I can't pay you for work that you didn't do. So
Correct.
this fixed costs, approach and paying for actual work
Yeah.
and has eliminated so much management overhead. I mean, that alone is such a worthwhile goal, and benefit of using something like event modeling and event sourcing. I think
Yeah.
event modeling plus event sourcing is like the ultimate thing. I still haven't seen
Yeah.
anything that even comes close to the level of quality, speed,
Right.
no need of management. That iron
Yeah.
triangle of quality, speed, and all of that is just squeezed into a very
Yeah.
tiny thing that you're not even thinking about it anymore. And then,
Yeah.
of
Yeah.
course, all of this leads into the future quite well, because you have such a predictable pattern of implementing things that you're
Right.
going to absolutely fly once AI has really settled where it's going to be.
Yeah.
We're in a brand new age where we're getting the next
Yeah.
level of abstraction, right? We came
Yeah.
from, just like Linus Torvald says, we came
Yeah.
uh, from
Truly next level. Yeah.
from doing assembler to having compiled languages like C. We came from just hacking C to having some IDEs and garbage
Yeah.
collection. So, we could refactor. We could not worry about cleaning up pointers and memory.
Yeah.
This is just another level of productivity, another level of abstraction. But, if you have solutions like this, where these patterns are just, they have so many examples, even in your own applications. Because if I had 50 types of patterns implemented in all my solutions, I would have such a small sample size for the use of each, that for me to
Right.
automate how my company works would be a lot
Right.
harder. I would have way more unreliable patterns because there's so few examples. But because I'm working
Yeah.
with two core patterns, command
Yeah.
handlers, and then state views or read models, whichever you want to call them, or projections, how
Yeah.
you interpret past events. Those two patterns are really how everything works, from things that are
Right.
automated behind the scenes to how people click things on a screen.
Right.
They're treated exactly the same. And so
Right.
that gives you a huge leg up on onboarding. I mean, that dream of like become productive on your first day at work, absolutely. Here you do
Yeah.
that all the time. We come back to solutions we haven't touched in 3 years, and someone asks for a new feature. That feature is done that day or the next day. There's like no ramp
Yeah.
ups at all.
Yeah. Yeah.
And that's through predictability, cadence. I think all these really awesome things that we want out of software, and eliminating the hundreds of problems that we have. We've done a lot
Right.
of that in this approach. And so,
Got it.
I'm happy to help everyone. And it's no longer just me. Like, going to our Discord server, there's so many good chats on there every single
Right.
day about how to apply this, how to shift
Right.
your way of working to this way of working, even not all at once. I mean, there's
Yeah.
really good steps along the way. A lot of people still, for example, even use Jira, and they can map these
Right.
workflow steps to
Of course. Yeah.
the Jira tickets, which is kind of cool. So there's a natural way of moving to this that's not going to disrupt
Yeah.
everything.
Right. No, that's amazing, Adam. So, quick question. Like, I cannot agree with a lot of what you've already said, and I think the responsibility is a huge thing when we start event modeling. I've
Oh, we
been
can
I've
have
been
a
fortunate to be part of.
session if you want. We can have one
Yeah.
or
Yeah.
whatever.
Now, the responsibility that the teams could take, the individual developers could take, the business teams could take, that is huge. And they could just run with one single document instead of having
Yeah,
84 specification
autonomy that
documents.
people and teams get is huge. The autonomy is
Yeah.
absolutely amazing.
Yeah. Yeah. Well, quick question in terms of, like, just for anyone listening, is like, oh, we are talking about different terms, like, okay, event sourcing, event storming, and event modeling. Would you briefly touch about the
Sure.
difference between, like, sourcing, modeling, and storming? Like, that I think will be really useful.
Yeah. So, event modeling is really about putting down on paper the information flow through a whole system, including what people
Right.
see on the UI, different people
Right.
along the workflow, what
Yeah.
things get stored in the system along the way. That's really the
Right.
simplest way to explain event modeling. And that's going to be the common ground for almost any kind of line of business project. You're not going to use this to make a new hashing algorithm. I'm not saying this is like a technical tool, but for
Yeah.
99% of the things out there, such as insurance companies, where most likely you're going to work making your next app or whatever, this is the thing that's going to communicate how your system works to everyone. That's event modeling. It's really
Right.
talking about information flow, how the system works, but it's talking about it in tech agnostic terms, meaning everyone can understand it. Like if you're automating one of my friends has a hair salon, and so automating that hair salon, I need to have an event model so that they understand how their system works, and even manual steps where you're filling something out and sending it out in the post office for ordering more product or something. You can put that on the event model. You can see the interface of manual process switching over to automated process. You can see how information travels between your inventory system and your point of sale system. You can see all that. And that's just taking, showing by example how information flows. That's event modeling. And I think that's the best one. Event sourcing is an approach to managing information that ensures you don't overwrite stuff. Currently, everyone treats things as cruddy kind of property bags that get overwritten. So when someone changes their address, the old address is only on the backup of that database back then.
Yeah.
Unless someone explicitly says, we need a history of your past addresses, you're not going to keep it. Event sourcing says you're keeping everything. You're not allowed to erase anything. So your events themselves are like statements of fact. And I like to redefine event sourcing as capturing information as it enters the system. The system's boundary. You don't really design events. It's not part of the design process, at least it isn't for us. We're really just capturing what information is entering that system and putting it down as a file, as whatever, on disk. And then everything else is secondary to that. If I need to use that information on this screen, I look at all the events that are relevant and show what I need to show. And if I need to show slightly different version of some of the information on a different screen, I do a different projection of that event plus some others maybe. And that's event sourcing on its own. So that's event sourcing. I'm sourcing everything from the events as they happen. And that's the breadcrumb trail that is so powerful that so many people dismiss, because the problem with event sourcing is that people have confused it with a lot of the infrastructure that people build around event sourcing itself. Event sourcing itself is the most simple thing you could do because it's just two patterns over and over again. It is CRUD and all these other things, just forms over data, are way more complicated. There's way more SQL involved and a whole bunch of stuff happening behind the scenes, updating indexes, looking at foreign key relationships and constraints and all these things that are actually quite complex. Yes, they're automatically done for you, but it doesn't take away the fact that that complexity is actually there. Event sourcing really is like, if I hit this button on this on this form, I'm just taking that information, I'm writing it to disk. That's event sourcing, finished, right? The other side of it is that I'm going to read that information at some point to display it. That's that. And event storming is really about having people use events and kind of going to a wall and talking about everything together. I still correlate event storming as a way to collaborate together with multiple roles, so that the developers, the business owners, anyone else has a medium of information exchange. And for us, that's replaced with event modeling, because we actually want people to see the screens that people are going to see. There's some criticism of that like the screens make you biased, and so that you'll think of less information. You'll push the solution. You'll solution before you understand the problem. Other things like that. It hasn't been an issue for us, and so we basically just do event modeling instead of event storming, because we want people to understand the UX and the UI and how it plays. Yeah. And we want to talk at that level. And a lot of companies, their concepts, the idea of their company is based upon what the founder has in the vision for what someone is looking at. And and I think UX and UI is extremely important. I think it should always be there. No matter how technical things are, you always have to think about how your underlying architectures are impacting the users at the other end. And I think that's what we've accomplished with event modeling.
Got it. I love that. Thanks for sharing that. I took this quote from Albert Brandolini, who's the creator of Event Storming. And then as we get closer to the wrap, please let me know if how we're doing with the time.
Go to the airport, but we can do a session.
I'll wrap up in probably another 5 to 10 minutes at best. Tops. Does it sound good? Okay, fine. So I just love to share. Okay, 5 minutes, good. So Brandolini said, it's not that it's not the domain expert's job to be formal in their language. It's our job to be formal enough to let them speak with their own minds. I think that speaks a lot of like how even modeling can help achieve in terms of like the flexibility of a formal language versus the flexibility of like how the business team wants to talk. So I think that flexibility plays a lot in terms of like the storytelling that we spoke about and the whole visualization aspect of how teams look at the whole product end to end. I think that's a huge plus for event modeling to like express that in a way people understand. Just a quick thought. I mean, like you did mention about Bitcoin and things like maybe your the last two questions, right? We have a rapid fire which will probably run for 2 minutes, but this will really close. Yeah. So this one, so you spend a lot of time on Paxos, and then of course you spend time on Raft, the consensus algorithms. Like speaking of consensus algorithms, like slightly off topic, what's your view on proof of work? It's yet another consensus algorithm, and like what's your thoughts on Bitcoin, real quick?
Yeah, I mean, I think it's it's really worked over a lot. I think there's a lot of it has had a lot of time to do that. I think there's a disincentive to spend Bitcoin, and it's kind of an unnatural goal for Bitcoin. So Bitcoin wants to be the currency, but it has anti-currency properties, which means you are disincentivized to spend Bitcoin because it rises in value because of the scarcity. So I think it's doomed to be used for what it is. I think it's going to be used as a medium of trust exchange. I can't really comment on proof of work or all that. I certainly proof of work versus what's the other proof? Proof of
reserve? No, there's proof of work and there is the Ethereum version, the other one.
Yeah, I mean, that is just trust. And I mean, event sourcing is the same thing. It's trusting that what I wrote on disk is the truth. And so whether you have who's adding those things, usually it's just the system. So you have to trust it because the interface is whatever. So yeah, I mean, Bitcoin is kind of digital gold is how I see it. People kind of want to have it as insurance. I mean, the seedy side of it is, the dark web and all that. So, and all the things that can get paid. I mean, you can use cash for that. So I understand these problems, but I'm less interested. I'm way more interested in AI than I am in Bitcoin. Let's just say that.
Okay, that's great. So we're going to hit rapid fire, then we're going to close and we'll call it a wrap. So quick rapid fire. It's like probably a short phrase or not more than a few words. Okay, so quick question. It'll be all very rapid fire questions. So what's your favorite programming language?
I mean, I love assembler, but I love JavaScript as well. So there's many loves of many different languages. I don't have one. I'm most proficient, believe it or not, in C# because I've done quite a lot of it. JavaScript is the one that I want to default to because most people will use it, and I think it's evolving. It has its issues, but I don't see syntax as the core problem, especially in the next years. This is going to be the entire world. I like Rust because it's made its way into the Linux kernel to get rid of the problems with C for a lot of development. And those are the big ones. I try not to be a fanboy because our company has to work with whatever languages our clients have, and so event modeling is tech agnostic for that reason, and so is event sourcing.
Good. One word to describe event modeling. One word or short phrase to describe event modeling.
I would say system schematic.
Nice. Very good. Morning person or night owl?
Used to be night owl, morning person for productivity now. Yeah.
Got favorite book?
Oh boy.
You'll have a lot, but like mention a few books.
The favorite technical book, the way it's put together, is Michael Feather's Working Effectively with Legacy Code. Even though I'm not doing TDD, I think the structure is really good. Concept is in the first 1/3, last 2/3 is all the patterns and how to apply them. Which is a really good format, and I think it's really good in terms of friendliness to learn stuff. Head first design patterns to really make it fun to read through a lot of dry stuff. That's another really good book. For an exciting novel that's real. Ghost in the Wires by late Kevin Mitnick about a hacker running across back alleys being chased by the CIA in helicopters. Doesn't get
Right.
better.
Right.
Those are good books.
Do you have any favorite? Sorry, go ahead. Like
actually, sci-fi. I really liked Anthony. What was this called? There's a really good sci-fi book I read. But anyway, we can get to
no
that.
problem. Did you have any favorite tech blogs?
I used to. It's really about following people on Twitter. Not many people blog now. I have some YouTubers that I listen to, but they're kind of quasi tech related. We have Electro Boom, which is a Vancouver guy.
Right.
I like Technology Connections from Ohio. He's really funny. Yeah, that's about it.
Good. What's your go-to productivity tool? The go-to productivity tool. You use it
AI.
every day.
Cursor AI.
Cursor AI. Okay,
Cursor.
Got it.
Yeah, Cursor
AI. Okay.
Everyone knows about that, and I've been using it for many months. Now people are catching up.
Very good. You're a coffee or a tea person?
Tea.
Tea. Okay, perfect.
Tea is, I think Polish people drink more tea than English people. But also, I drink a lot of tea.
Amazing. Distributed systems or microservices?
Whoa.
You just have to choose one.
I think both have a bad rap. I think there's place for them. Yeah.
Got it. Your dream vacation destination where you have not gone yet?
Always Maui.
Maui. Okay, perfect. Last question on the rapid fire, and we're going to close. So AI, is it hype or future?
Future.
Perfect.
It's not cool, but it is the future.
Okay, Adam, thanks, and it's a pleasure having you on the show today.
Let's do some more deep dives. I want to do this again.
Yes. Yeah, we will do deep dives. Thanks for having you on the show today. Where can people find you, and tell us about the event as you wrap up as well?
Group.com, on X or Twitter, whatever you want to call it. Dymitruk there. Event modeling also on Twitter. YouTube, event-driven systems. Just if you Google event modeling, my channel is there. I do live streams on Twitch and LinkedIn and all that. LinkedIn is really good. I post a lot of relevant things there. Twitter is more fun. I post some jokes too. But if you just want pure technical stuff, the event modeling, the Twitter or X channel's good. And LinkedIn is good for technical stuff, and YouTube is really good. Just search for event modeling. You'll see it there.
And the event is happening on September?
Tomorrow. So September 9th to September 13th, 2024 is the workshop. So September 14th is the conference. Do not miss that, because that's going to be an awesome unconference. We have keynote speakers there, such as Dave Thomas. That's a very influential person, and so it's going to be quite an awesome event, and the first one in North America. So hope to see.
Amazing! Congratulations, Adam. Adam, thank you so much for having today. I don't want to delay for any further to your airport, right? So thank you so much. I appreciate the conversation.
We'll do another one. Thanks so much.
Yeah. Take care. Bye-bye.
Have a great day. Bye.
Yeah. Bye.